This video is on natural log integration. So basically, remember that the derivative of the natural log of x was 1 over x. Therefore, pretty straightforward, the integral of 1 over x dx is simply the natural log of x plus c. However, we do need to restrict the domain of this, so we need to add absolute values here. So the integral of 1 over x dx is the natural log of absolute value of x plus c. This is pretty useful, but it's not super useful because, 1 over x isn't a very common function. But we do have to extend this to include u-substitution. So if I do the derivative of natural log of u, then I get 1 over u times u prime. And this is a more common integral where I'm integrating the derivative of a function over the function itself, dx, and this will get me the natural log of absolute value of u plus c, and this will be an okay thing to do. A very common u-substitution with natural log is basically a constant divided by a linear term. This falls into a good u-substitution category where the stuff and the derivative of the stuff differ by a power of 1. So this is really x to the first on the bottom and x to the 0 on the top. This is a good candidate for u-substitution. So let's let u equal x minus 1, and actually let's change this a little bit. Let's say the original problem is 4x minus 1, so then I have to let u equal 4x minus 1. Then my du will be 4 dx. Well, I have the dx here. I just need a 4, so I'm going to doctor with a 4 on the top and counterbalance on the outside with a 1/4. Notice that I can't cancel these two 4's because there isn't a 4 in the other term of the denominator. Sorry. So now I can make the substitution. I'll have a 1/4 on the outside from the counterbalancing. I'll be integrating, and then the bottom piece is very nice because it just turns into the u. So I have blank over u. And then on the top I have a 4 and a dx, which is what I'm looking for in the du. And so I'll be having basically 1 over u du, and this is my basic integral. This is natural log of absolute value of u. So my final answer is 1/4, no, it's not my final answer, sorry, 1/4 natural log absolute value of u plus c. I'm not done yet because I need to substitute back in the x's, so I plug them back in. So I got 1/4 natural log absolute value 4x minus 1 plus c, and this is my final answer. So it's kind of weird because we started with clearly an algebraic fraction and we ended up with a weird natural log thing with fractions and I don't know what else. But that's how it works, and it's pretty easy to do it once you get the hang of it. Sometimes natural log integrals can be in sort of interesting formats, like this one. And so in this one, the trick is to figure out which stuff should be the u. If you just take a guess, you could say, well, let's let u equal x. Alright, let's try it. So then du would be dx, and if I rewrite this integral, I would get 1 over u ln u du, which, if you notice, really doesn't help me because I've managed to rewrite the initial problem with a different variable and it hasn't helped me at all. So this is not a good substitution. In fact, this is never a good substitution because you'll just end up rewriting the original question with the different variable and have the same problem. So a different substitution we could make could be, let's let u equal ln x. That might be a better thing because, it's sort of stuff in a way. I don't know. Let's try it. Then my du will be 1 over x dx. So let's try to rewrite this. I'll have integral of 1 over stuff, because the ln of x is on the bottom, so I'll have 1 over u. And then notice what's left. What's left is the dx, so I'm good there, and 1 over x. The x is on the bottom, and so I can replace the 1 over x and this dx with the du on top, like this. Now I can integrate because this is a basic integral. So the integral of 1 over u du is the natural log of absolute value of u plus c. I'm not done yet because I have to substitute. So substitute in the u, and I'll end up with the natural log of the absolute value of the natural log of x plus c. It's a very strange integral, but that's how it works out. And you can see the reverse chain rule if you were to take the derivative of this back again. The integral of tangent x dx. This is strange because this is like a trig function. And trig things should have really nothing to do with logs at all. However, in calculus they do. So check this out. As it's written, we can't do this integral. However, we could rewrite tangent, and we'll see that that will make things a little bit nicer. Ooh, tangent is sine over cosine of x dx. And now, do I have 1 over stuff and the derivative of the stuff? Well, I sort of do. Check it out. I have 1 over cosine. So let's let u equal cosine of x. Because then my du will be negative sine of x. And I notice that I do have a sine of x right here. So my du is negative sine of x dx. Can I replace stuff? Yeah, I can try. So I'll have u is on the bottom, so blank over u. And then, oh, check it out. I have a dx here. I'll do this in red. Dx here, dx here. Sine of x here, sine of x here. Oh, all I need to do is doctor up with a negative, like -1 because it's a constant, and then counterbalance with a negative on the outside. So my final integral, once I rewrite negative sine of x dx with du, I'll have 1 over u du. Oh, this is natural log. And so my final answer will be negative natural log absolute value of u plus c. Remember, I'm not done because I have to substitute back. And when I substitute back, I'll get negative natural log absolute value cosine of x plus c. And this is, in fact, the integral of tangent of x dx. So just like tangent of x, there are similar integrals for the other the other 3 strange trig functions. So cotangent, secant, and cosecant. These are in a book, or in your book, there's a chart in this section that will explain how to find those. But you do have to know how to find each of these or memorize them. But if you forget, the easiest way to remember is to use u-substitution to come up with this answer again.